This says at the end of an advertising campaign, the weekly sales declined. The weekly sales in dollars are modeled by this equation, where X is the number of weeks after the end of the campaign. Okay, so this is why a problem like this might be a little confusing at first. What you have to realize, what's required of you in terms of understanding initially, is that you realize that this minus 0.08 that you see up here is indicating an exponential decay function. That said, the other thing that is being indicated is the starting point, which is 12,000. So knowing that is really key to understanding this problem. The fact that it's starting, and the fact that it's starting at 12,000 and the fact that it's an exponential decay, and you may more easily see that it looks something like this, very roughly. You may also realize, because it's exponential decay, that this curve will decrease, but never go underneath the x-axis. It'll always remain above the x-axis. Okay, so knowing that, it says determine the sales at the end of the campaign. Well, that is when, that's an A. That's when X is 0. Well, when X is 0, the output is 12,000. Because this is 0. Anything to the 0 power is 1. And so this is 12,000. So the tricky part is that it says at the end of the campaign, and you need to know that 0 is the end of the campaign. That's not obvious. This is at the end of the advertising campaign. And then it says determine the sales 6 weeks after the end of the campaign. You're going to plug in a 6. Which is going to be hard for me to do here, but let me give it a try. 2 to the negative 0.08 times 6 and then multiply that by 12,000. I am getting 11,607. And it kind of makes sense. So when you go 6 this way, this goes down a little bit, and that's the output. Does the model indicate that sales eventually reach zero? No, remember this thing never goes to zero. It never goes underneath the x-axis.